Here's a problem. Integrate cosecant squared 2 theta, cotangent 2 theta, d theta. We'll see here that it's possible to have different substitutions for u and still come out with a correct antiderivative. So let's start with, the problem's going to say, let u equal cotangent 2 theta. So we need to find du. Du will equal the derivative of cotangent, which will be negative cosecant squared 2 theta, times the derivative of 2 theta, which will be 2, and then d theta. So now we look and see what do we have here. We have cosecant squared 2 theta and d theta, but we don't have the negative or the 2. So let's say negative 1/2 du equals cosecant squared 2 theta d theta. Now we can do a straight substitution. Cotangent of 2 theta is u, and then cosecant squared 2 theta d theta will be negative 1/2 du. So this integral becomes the integral of u times negative 1/2 du, or negative 1/2 the integral of u du, so it's negative 1/2 u squared over 2 plus some constant c. And that can be simplified to negative 1/4. U is cotangent of 2 theta, so this will be cotangent squared of 2 theta plus some constant c1. Now let's go and try the other substitution. We'll let u equal cosecant 2 theta, so du now will be negative cosecant 2 theta cotangent 2 theta. It's always going to be negative cosecant cotangent times the derivative of the inside, which will be 2, and then d theta. So we can do the same thing as before. Negative 1/2 du will equal cosecant 2 theta cotangent 2 theta d theta. Now it might be helpful to take the original integral and break it up so we can see this a little more clearly. This is cosecant 2 theta times cosecant 2 theta, that will give us cosecant squared 2 theta, times cotangent 2 theta d theta. And now we can see that this part right here, the cosecant 2 theta cotangent 2 theta, is what we have, negative 1/2 du. And then we have cosecant of 2 theta, that's our u. So this becomes u times negative 1/2 du. So we have negative 1/2 the integral of u du, negative 1/2 u squared over 2 plus some constant c2, negative 1/4, and u this time is cosecant, so it's cosecant squared of 2 theta. Now we have the same problem, did two different substitutions, and we have two apparently very different antiderivatives. Part C of this question is confirm each integration is right. So how would we confirm it? Well, it's what we should be doing every time, and that is finding the derivative of it. So let's find the derivative of the first one. So we'll say I. We have negative 1/4 cotangent squared 2 theta plus some constant c, and we're going to find the derivative with respect to what variable? Our variable here is theta, so we're saying with respect to theta. We have cotangent squared, so that is our outside function, the squared. We're going to say leave the constant alone, negative 1/4 times 2. The inside function there is cotangent of 2 theta to the 1 less, or 1, and we don't need to write that, times the derivative of cotangent theta, and that will be negative cosecant squared of 2 theta. Now we're going to go the inside of there times 2. And when we simplify this, we have a negative and a negative. 1/4 times 2 will give us 1, and we're left with cosecant squared 2 theta cotangent 2 theta, which is exactly what we started with for our function, for our problem. Now let's check the other one. I'll call this one 2i. So we'll take d theta of negative 1/4 cosecant squared 2 theta plus c2. Again, leave the constant alone. We bring down the 2 times cosecant of 2 theta to the 1 less, and we don't need to worry about that, times the derivative of that inside, and the derivative of cosecant is negative cosecant 2 theta cotangent 2 theta times the derivative of that, and that would be times 2. Again, let's simplify that, and we'll get cosecant, we have a cosecant times cosecant, so cosecant squared 2 theta cotangent 2 theta. So we've shown that these two are both antiderivatives of this integral. Part D, we know that antiderivatives, slide this up a little, antiderivatives differ by at most a constant. Find the constant. So what we want to do here is we want to say cosecant squared, we're going to say negative 1/4 of cosecant squared 2 theta is going to equal negative 1/4 cotangent squared 2 theta plus some constant, and I'll call it C, and we have different letters, C1, C2, C, so we can know that they're all different. And in essence, C is C1 minus C2 here. We can multiply everything by, actually we want to solve for there, so we need to simplify. We need to find the relationship between these. Now recall your trig identities. We know that sine squared theta plus cosine squared theta equals 1. And if we want to get a cosecant squared or a cotangent, what we would need to do is divide everything by sine squared. So when we do that, we will get 1 plus cotangent squared theta equals cosecant squared theta. And since theta is just the angle there, it really doesn't matter that we have 2 theta as long as they're both the same here. So we have cosecant squared equals 1 plus cotangent squared. Let's make that substitution. We have negative 1/4 times 1 plus cotangent squared of 2 theta equals negative 1/4 cotangent squared of 2 theta plus C. Multiply this out, we get negative 1/4 minus 1/4 cotangent squared 2 theta equals negative 1/4 cotangent squared 2 theta plus C. The negative 1/4 cotangent squared will go away when subtracted, so we get C equals negative 1/4. So yes, indeed, these two antiderivatives, negative 1/4 cotangent squared 2 theta plus some constant, and negative 1/4 cosecant squared 2 theta plus some other constant, differ by a constant. They differ by negative 1/4. And that is all.